Welcome back, everyone, to AI Week. I'm Stephen Warren, and I'm the CTO of DatacenterDynamics, and an absolute pleasure to have us joining you. I mean, right now it's just an absolute joy to talk about this part of it. AI's hidden challenge. Powering high-density environments is so critical these days, and a big thank you to ZincFive. Brandon Smith, the Director of Product Management at ZincFive, we appreciate so much that you're doing this with us. Nabeel Mahmood, Chief Executive Officer at Nomad Futurist, an absolute pleasure. Everyone knows you so well. And of course, what a pleasure we have got with us today, Shawn Dyer. You're the Director of Electrical Engineering at Vantage, and everyone knows that great company. Thank you so much for joining us. Let's get right into it. The first topic is your perspectives. Introduce yourself, please, about you, about your company, but more importantly, can you also talk about what's going on these days, this whole idea of AI's hidden agenda and this whole power density issue? If I could, right to you, Shawn, what's going on? What are you hearing? Your Advantage. You've got all these customers dealing with it every day, my friend.
Exactly. Yeah. My name's Shawn Dyer. I'm the Director of Electrical Engineering for Vantage Data Centers. We're a hyperscale data center development company, and we build and lease data centers to the largest hyperscalers in the world. And, everybody is looking for the AI factories now, right? It used to be, large cloud campuses that were a couple hundred megawatts. Now it's everybody wants a gigawatt plus of compute for these AI factories. And um, it's a changed world, as everybody knows, right? Used to be with cloud, you'd ramp into your load and you'd stay there. And now with AI, our customers want us to solve for the impacts of the large GPU workload swings, including the 50 millisecond excursions, which they're calling them, right? Which means, from 0 to 150% of load, which, could be absorbed on smaller campuses. But when you're talking about a gigawatt of compute, that could be 100 megawatts of extra load that happens, on the campus at the grid. So how do we solve for that? And that's what we're trying to do. And, right now it's the leading edge. Nobody really knows. And, the companies that are leasing facilities from us that are stuffing all these GPUs in there don't want to throttle the GPUs because they're paying for the performance, right? And so this is how they're operating. And so they're saying, help us solve the problem, right? And that's what we're trying to do.
So I've got to say, Shawn's brought up a lot of points, Brandon. Yeah. But the thing is that ZincFive's already there. So I'll get to Nabeel in a moment. But right now, to you, Brandon, please introduce yourself, Director of Product Management, critical at ZincFive. But how you're seeing what's going on right now, your perspectives. Brandon, you're seeing a lot with a lot of players.
Yeah, absolutely. So my name is Brandon. I'm Director of Product Management at ZincFive. So my responsibility is to bring nickel-zinc-based technology solutions to the data center. That's centralized UPS batteries. That's potentially batteries in the rack, generator start, lots of different kind of applications. But for today, a lot of good points from Shawn. The AI dynamic workload or spiky load, or pick your term, right, is the process at which these accelerators are optimal, and they fluctuate power demands very quickly. They ramp up temperatures very fast, and they ramp down compute very fast. And all of these pulses or spikes or dynamic workloads create electrical issues on infrastructure. So legacy designs typically struggle to keep up, and even modern designs struggle to truly mitigate or accommodate these pulses without drastically oversizing your electrical infrastructure and increasing your CapEx quite a bit. Anywhere from 15% to 40%, depending on the literature that you kind of are reading and what your infrastructure looks like. So, for us at ZincFive, we're a technology company focused on advanced battery solutions. What we do is high power, short duration. We're an immediate power solution as opposed to an energy storage solution. And we're just looking at how can we fit into this? How can we help people like Shawn? How can we help the data center market by putting batteries at the UPS or in the rack to potentially absorb and mitigate these power demands? So yeah, Shawn said we're right on the cutting edge of this. I don't think anyone has an answer, but we're all working pretty hard to design better for the future and keep sustainability in mind while we do it.
while keeping sustainability in mind and energy efficiency and operational control. And I love Shawn's point, the critical inflection point. Now, Nabeel, I'm turning that critical inflection point over to you, my friend. Please introduce yourself, but also your perspective on this.
All right, brilliant. So Nabeel Mahmood, I'm the Chief Executive Officer of Nomad Futurist and Mahmood Group, board member, advisor to multiple global companies across artificial intelligence, data centers, and data infrastructure. My work primarily is centered around helping organizations understand not just where technology is going, but how to responsibly build the future. The challenges that we are going to be discussing here are really critical. We are at that inflection point that we haven't seen in decades before. I really do believe this is the beginning of time. What we have done in the last 4.5 decades is just testing the waters. This is it, folks. Now the real ride begins. Now is the fun time to make a change and contribute to the betterment of humankind.
So I've got to ask, you're advising so many incredible people, Nabeel. Are they asking about this? Is this something you're hearing more and more? Because it's something you're responding to every day to great companies.
Absolutely. Every conversation that I have is about AI. Every engagement. As a matter of fact, people are not in the space even. They're talking about artificial intelligence. And the interesting part, and Stephen, you and I had this conversation before, that this is nothing new. It's the scale that we're growing at, the amount of power density that's needed, the amount of compute density that's needed, that's defining where we're at. Compute has changed and evolved traditionally from siloed to static models to dynamic, and now it's all integrated. Now, where we have the ability to actually define processes to predict and analyze data at much larger scales.
Shawn, I'm going to ask you, Nabeel just brought that up. It's absolutely, it's not new. You've seen this yourself before, I know that. And you've also had to deal at Vantage with increasing densities in racks. Is this something that you're seeing more and more where it's impacting you day to day, the spiky loads, the issues around? Because assets, these are all assets to you, all the infrastructure, all the CapEx that's put in for your customers. Your thoughts on this, Shawn?
No, it's a great segue, right? Is that it's not new, but the rate of change, the slope that we're expanding, we're hitting a wall, right? Things, data centers that are getting deployed now were designed a year or so ago with infrastructure that was purchased a year or so ago that could handle 40-ish kW a rack, and now it's 100, 150 kW a rack, or they were 4 megawatt data halls, and now customers are asking for 2.5 megawatts per row. And so it's and it's not only the spiky load or excursions, because I know some companies don't like the word spiky. That how do you plan for that, right? And it's also the load steps. The GPUs can go from 20-30% load to 100% load immediately. And the grid isn't set up to handle that, right? So how do we as an industry get ahead of this? Because a lot of the stuff is based on technology that's getting developed that isn't going to be deployed for another year, right? So we're even guessing of what's going to be coming, right? So now we have 100 or 150 kW racks, but they're saying, you're building this facility for us now, you need to plan on 250 or 500 kW a rack. And, the utility companies are going, what does that mean to our grid, right? So as an industry, we have to come up with all these different solutions. And there's right now, we don't have one answer because we don't really know what some of these load profiles are actually going to look like, because the final GPU designs aren't done, right? So, our approach is, we're in this together as an industry, right? And, talked about sustainability and maintaining good communities and being good neighbors, right? Because we could impact the local area's grids significantly, right? We saw that in Northern Virginia when a bunch of, 1.5 gigawatts of data center capacity went offline, right? Can you imagine those load swings now in one campus, in one rural community? And so that's our approach is we're all in this together. we need to be working together to figure out, what's the solution today, but also what's the solution for tomorrow. So.
Yeah, I think Shawn brings up a great point. I mean, the low densities, it's not that long ago that we were still operating in 1.5 kilowatt of rack space to now we are in talks of 1.5 gigawatt of rack space. So that's only happened in the last 25 years of folks actually doing this all, right? So a part of the challenge that I see where we have is all the silos that we have in all the layers of the data infrastructure. So the AI folks are not talking to the software folks, are not talking to the technology stack folks, are not talking to the facility folks. And that's where the gap gets very challenging, that we don't all have the same driver and or the result that we're seeking or the same key performance indicators that we're pursuing. So if we can get everybody together, ideally, then we can scale up at a much faster pace than we are doing so right now to address some of these gaps that we continue to see. I mean, there are smaller challenges, right? I mean, when you have rack densities going from 1.5 kilowatts to 100 kilowatts, I mean, just basic load density, the physical load density per square foot becomes an issue as well. And we're not building those infrastructures, putting power aside just for a minute. Not to mention, if there's a transformation as well from AC to DC, and not just going from AC to plus minus 48 volt DC. Now, should we be considering 400 volt? Should we be considering 800 volt DC to the rack to accommodate that compute density that we have not designed or provisioned these environments for? We are not ready to scale up that quickly. So in my world, I suggest let's step back a bit for a second. We know this is the future. We know that we're going to need that much compute capacity within that square footage. We know that there is going to be that much demand. We just need to collective effort in addressing these challenges as we scale up.
Yeah,
Perfect point.
I was going to add to that. I mean, you mentioned it because you talk to a lot of customers, and we do as well. And I think Shawn and his team are top notch, and they're right on the edge of all of this. But it's about coming together to talk about the challenges and not hiding in your own silo trying to solve it, because it is industry wide, and the amount of gigawatts that need to be developed for this to be, to reach its peak, it almost becomes a matter of national security, right? How fast are countries building AI? How fast are they dedicating the resources to it? Are we working together to fix these challenges? You mentioned kind of high voltage DC, running that direction, running this direction. So that's why I think these conversations are so vital. And as a vendor to the industry, right, what I do is I want to learn. I want to learn what the problems are, and I want to see where we can solve those problems with our technology. And the only way we can do that is with open conversations about what we're really good at and what problems the data center providers or hyperscalers have. And I think we're getting there. We're starting to have these really good conversations about what matters today, what are we designing for in the future. And that's part of why I think these talks are so important.
Let's move forward. Let's go to the next point here, which is really talking about this is not sustainable. And Nabeel, you're the one who brought this up. Deal with it. I love that. When we chatted before, I thought that was so simple and so perfect. How are you dealing with it? You even brought up, Nabeel, we got bottlenecks, and Brandon jumped into the too about solving them. So I'm going to throw it at you. Nabeel, what's going on here? How are we going to deal with this?
Well, we've outgrown at the pace. Like, I think just stepping back in time for a minute, before COVID, we talked about digital transformation. I mean, it was sort of like a dream. Remote workforce was sort of like a dream. Being nomadic was really a dream to work from anywhere in the world. I still remember we used to measure success of a company by the number of bums in the seats or the number of cars parked in the parking lot. We are striving, we're doing great, to now, okay, you can work remotely. That accelerated the sector, whereby artificial intelligence came to the forefront. We've got a lot of other digital sets and tools that came to the forefront as well to help with the transformation. So we did not design an infrastructure that was ready for it at the scale that we have grown in the last 5 years. So there's been a significant shift in computing. And then, of course, the generational impact as well, that the new digital natives are born with it, right? It's available at their fingertips. It's muscle memory, and they live by data. They want that information immediately right now. So what it's done is started to create a significant gap in KPIs, in business units, whereby we're not talking to each other, but we're deploying a multitude of applications and large language models to grow our specific domains. Now, if we can get all together, we solve the problem. But as it is right now, I believe we are heading into a potential catastrophe, that this is going to fail. And when I said deal with it, someone's got to be held responsible, right? So I mean, that comes in from the executive level. I've got to make sure that my business is up and running, my business is productive, and I can keep the shareholders and my partners happy, which means that I need to have a good understanding of how every single business unit or business unit leader is running, what data are they collecting, and how do they build the infrastructure that's available to not only sustain, but to scale up as well. So communication, transparency are some core elements that need to be addressed. And that's why we also have seen the fact of the spikiness that we continue to talk about, right? So with large language models, the acute needs are changing. And that's causing the spikiness. And it's also helping us understand the criticality of data, that without data, there's no business. I mean, you can't run a mom and pop shop because you can't process credit card or can't have credit card information to large organizations. So the bottleneck is us. The bottleneck isn't necessarily, in my opinion, the grid. It's the processes, the lack of communication. It's not prioritizing what's needed for the business. Hence, the challenges come with the power limitations or the design constraints that we put forth.
I like that term, constraints. Constraints in design, constraints in infrastructure, constraints in silos, issues of data lakes. But also there's so many other issues because, Shawn, you're dealing with customers too who are taking the hyperscalers, who are some of the smartest people on the planet, I think. And you're dealing with them. Shawn, your feeling about these bottlenecks, are you seeing it? Are they seeing it? What are they? And a lot of your customers also have their own, to Nabeel's point, compliance requirements, government, country, inside, outside, customer base. How do you deal with all this, Shawn?
Yeah, it's a brave new world, right? Like when you think about it, like Nabeel brought up a good point. It's everybody's focused in on the power constraints, but I like to say it's a supply chain constraint, and the supply chain could be anything from personnel, right, to companies like ZincFive, right? Going from producing 500 megawatts of capacity a year to 1.5 gigawatts of capacity, or new technologies to handle the AI workloads, right? These are new technologies, and if we're procuring equipment 2 years in advance, well, they don't have the supply chains to ramp up into this, right? And then, like you said, from sustainability, because all of the large customers are now wanting, compliance with their ESG requirements. And so it's a very big balance to understand the impacts of all of that, right? And I think, to Nabeel's point, one of the biggest supply chain constraints is going to be in personnel, right? 15 years ago, 100 to 200 megawatt campus was a large campus, right? And one of those campuses would have 1,500 laborers on site every day, not to mention all of the people with the developers or hyperscalers or whoever who are managing the project. But now think about a gigawatt campus, right? It's going to grow exponentially. We're going to have to create small towns around these things. And where do we find those resources, whether they're equipment or people or, compute capacity, right? It's all coming to a head. So.
Yeah, and what if the gigawatt rack comes to reality? I mean, that's not that far out. I mean, I believe within a decade we'll be right there, and time is just flying by so quickly, right? That's just literally around the corner. So we have to start thinking 7 to 10 years out as an industry.
Yeah,
Nabeel, we're already at the 1 megawatt rack, my friend. Genius. Brandon, I'm turning it to you. There's so many issues here. Sustainability of the life cycle of equipment, sustainability of staffing, sustainability of the utility, and geez, there's so much. But also, Brandon, I need your help here because there's also a battery issue, a chemistry issue. Can it even handle it where we have been in the past with our own designs? Do we need to be new thinking here, new chemistry thinking, new infrastructure thinking, new design? To you, Brandon, please.
Yeah, no, it's a good question. I think the personnel conversation here is really interesting because most people believe that AI is here to take jobs, and I'm sure some jobs will be better facilitated by AI. But AI is also here to help people in their current roles be 10 times more capable. So it's going to make everything more efficient potentially. But you end up in this catch-22 where you need AI to deal with the people shortage and you need people to build the infrastructure and backbone of AI. So, focusing on what we can do to build that more efficiently and more sustainably is key. And unfortunately, I think the way to solve some of this today is to just overbuild the infrastructure so that you have capacity in the system, from oversizing breakers, oversizing UPSs, oversizing utility lines, utility interconnects, which of course are already a bottleneck. And like Shawn said, passing those pulses, those dynamic workloads onto the grid and dealing with it later. But if we look 2-3 years down the road and we over design all these data centers to at least allow these pulses to come through the infrastructure without taking that data center down, the buck stops at the utility and it will become a problem there. And so thinking that 7 to 10 years down the road, like Nabeel said, we have to start planning our infrastructure for what will happen. And we believe what will happen is the utility is not going to be capable of facilitating these type of megawatt, gigawatt level swings depending on the infrastructure size. So overbuilding is not sustainable. It's not capital efficient. It's not sustainable from an emissions perspective, let alone sustainable from a capital or a supply chain perspective. So it's about looking at new opportunities, new technologies, and trying new things, and planning for that future. And what we're trying to do is, as a high power, short duration battery product, we have the ability to discharge high power very quickly over a 50 millisecond type interval, and then recharge very quickly as well as that GPU load swings back down. And traditional chemistries, aren't really prepared for that. They're not made for these microcycle high power discharges. And so if you're using kind of current infrastructure, whether that's in rack or at the centralized UPS, these technologies are really going to struggle. What we thought of as cycling capable products were 1,000 cycles, 10,000 cycles, maybe 500,000 cycles was the upper peak of cycling capability. But if these pulses are happening every 1 to 10 seconds, depending on that GPU cluster size, the workload that's being run, all the different variables that go into making Shawn's life really difficult, these pulses could be tens of millions or 4 million a month if it's every second, right? So we have to start thinking about technology and batteries in a different way. And if we're going to be consuming batteries to mitigate these, how do we do that sustainably? To start with a chemistry that's easily recyclable, build a circular economy around that. Lots and lots of things to discuss, but I think there's a solution out there, and it's just engaging early in that design. So we're planning for that 2, 5, 7 year 1 gigawatt rack, which I hope is 10 years away, Nabeel, because that's going to be a game changer.
So
Let's move on. No. Let's get on. You guys can talk about what you're up to these days because I love this. A new mindset is needed. And we need to have this conversation. Let's get it back to you guys. Projects, case studies, lessons learned, things you knowing. Let's get to it. Let's talk about the new mindset. Nabeel, to you, please.
Yeah,
new mindset, my man.
Yeah, so I think Brandon actually hit the nail on the head. I mean, without standardization, we can't really scale. We need the reference architecture. We need shared design. We need to be collaborative. We need something like open compute and or other organization initiatives to collaborate and bring the industry together to solve this puzzle. It can't be just one vendor taking the responsibility of the world. It's got to be inclusive. And Brandon, talking about batteries, I think you guys are on the front line against the volatility. It's no longer just about having runtime. I mean, that's the old mindset. It's about response time. Batteries and what ZincFive is doing is, I'm a firm believer that you've got to have that level of intelligence built within the batteries. They got to be integrated and adaptive to the load shifts to better understand the spikiness of the large language models and artificial intelligence that's going to just accelerate as we look into the next 5 to 10 years.
Shawn, can I turn it over to you, please? Boy, there's so many things we've got to think about with all of this. Anywhere you want to go.
Yeah, I mean, I think the biggest thing is that our infrastructure was built for a previous product, right? And Brandon, I think, mentioned in 2 or 3, passing the buck down the road 2 or 3 years of the utility. Well, we're already seeing it with air-cooled AI, 32 megawatt buildings that the utility is not able to handle it, right? Much less, those are sub 50 kW racks, right? Now, go to the 100 kW, 1 megawatt, 1 gigawatt racks. How do you handle these load swings, right? And the utility infrastructure is not set up for that, right? Our people infrastructure, our current technology infrastructure is not really set up for that. And I think Nabeel hit it on the head. We need to be inclusive and collaborative, right? It's not going to be one solution that solves this, right? It's going to be trial and error, figuring out at multiple levels, implementing solutions, right? That's the route we're going, at the rack or row level, at the lineup level, at the building level, and at the substation level to assist the utility, because utilities have caught on. And when you go to get power agreements, they're saying, hey, you need to limit your disturbances with under a certain percentage, right? And how do you manage that, right?
Brandon, to you, how do you manage it?
Yeah, well, you can hopefully do it in multiple ways, and that's what Shawn was kind of mentioning. So in the rack, at the UPS, at the grid, depending on how much power is needed and how much pulsing is going on, is it 20 kilowatt a rack, or is it 50 kilowatt a rack? And what is the capability of the chemistry you're looking at? So how many of those devices do you need? And then at what voltage? Is it a 48 volt type architecture? Is it a AC type architecture, or are we talking about high voltage distribution to get to that 1 gigawatt rack level? There's a multitude of ways, but it really just starts with having the right chemistry that's capable of doing something like this. And there are others out there. We're not the only ones with a good chemistry for this application. It's going to take all of us to truly bring the level of AI to the market that's being projected out there. There's a lot of different ways to do it. Personally, I believe the closest to the source is the right way to manage it. So if you can put it in the IT rack or next to the IT rack, as close to that GPU as you can, that's probably the most efficient, because the upstream architecture is not being affected by those 50 to 100 millisecond type swings. Otherwise, your breakers, coordinations, trip studies, things like that, UPS sizes, all of those need to account for some oscillation upstream. For legacy data centers, or something where the infrastructure is kind of well set, but a customer is coming in with some AI load, potentially replacing the batteries on the UPS with something that has a higher cycle capability, and then utilizing that UPS to lean on the batteries periodically to take out those major harmonics is an option as well. And then moving up to the grid, as Shawn mentioned, utility. So medium voltage architecture, whether you're putting the backup power infrastructure out at the grid and using a medium voltage UPS or a solid state transformer or something like that, there's opportunities to put the products there. So a lot of flexibility.
Yeah, and just to add to it, I think both Shawn and Brandon actually make great point. I think we need to be inclusive of the technology stack and the application stack as well. So maybe does it make sense to silo your processing versus your storage into two different environments? Maybe we need to actually consider load balancing at the large language models as well, right? So that we don't strain the physical layer or the physical assets. So we need to bring everybody together to speak the same language to ensure that we are not putting strain on the physical layer and or the grid itself.
Perfect. Shawn, to you, Vantage has been one of the greatest companies in this. You have led. You have seen the issue before so many others, and you work so closely with your customers and hyperscaler. What are you seeing in terms of a new mindset? Have you guys really, I mean, you have a new mindset all the time. Is it just changing more? What's happening?
Yeah. I mean, it's like I was saying, we're designing facilities for customers, and it starts off at 1 megawatt a row, and then 2 weeks later it's 2 megawatts, and then 2 weeks after that it's 2.5, right? And I think we've made the point several times is that we're all in this together, right? I don't think one person or one solution is going to be the silver bullet today, right? Um, I think we all need to collaborate and figure out this together, right? Because we're at an inflection point, right? And as Nabeel said, 25 years ago, we were at, 1.5 kW a rack. And, I remember 15 years ago, customers saying, oh, we're developing for, 8 or 9 kW rack. And they're like, well, we want 20 kW rack, right? Okay, you're never going to use that, and now look what we're talking about. It's like, it's not projections, it's real, right? But the challenge is that technology is moving so fast. How do we stay ahead of it, right? Because as Nabeel mentioned, gigawatt racks, and everybody's like, oh, that can't happen. Well, that's what we said about 20 kW racks, 15 years ago, 10 years ago, and look where we're at now. So, a 20 kW rack is a standard networking rack,
Exactly.
And so, how do we plan for this massive change, right? And the thing is, it's changing so fast. Even the customers, only can project what they're going to be installing. And like Nabeel said, how do they manage their stack under the constraints that we're developing for now, right? So it's not just one of us. It's just not Vantage as the developer providing a solution. Mm-hmm. That's not Brandon and ZincFive providing a solution. It's not Nabeel advising the customers as a solution. It's the whole value chain of everybody working together to say, what do we do now based on our best guess of where we're going to be in 2 years, much less 5 years. And that's the challenge that we're seeing every day is, constant communication with customers, which then we turn around and are in constant communication with vendors like Brandon's team of how do we solve this? Here's late breaking information from our customer. What are you guys seeing for that? And so they continue doing their testing and modeling and R&D and saying, okay, well, we think this is the new solution.
I got to ask you, Shawn, are you really seeing also the grid operators be part of that new collaboration? Because they have to be, or you have to tell them they have to be. So you're seeing it from the grid players, the utilities also?
Yes, yeah. I mean, they're more they're more like old school, traditional, a ramp into load. They develop, and they're under a lot of constraints, a lot of regulation. If you want a new transmission line, it's going to take 10 years to get through permitting and everything else, right? So, right now, we don't have as much of a power generation issue. It's a distribution. It's getting it where we need it, right? So what you're seeing a lot is the utility companies wanting to participate, but they're constrained under their existing regulations, right? And so in the interim, you're seeing a lot of self-generation, like temporary self-generation behind the meter type stuff to get campuses up and running until the utilities can come in and support. And so once again, it goes back to everybody working together, right? The utility says we can do that for you, but it can't be until 2028. And the customer says, well, we need compute in 2026. So then, work with some different self-gen solutions to provide that bridging power, through. And it used to be bridging power. We're talking 10, 20 megawatts of power. Now you're talking 200 megawatts of power, to help support the utility in delivering a solution, because they want the same thing. They want a solution that satisfies all their customers, right? We're just one portion of that, and we need to be mindful of that. What we're doing can't impact their other customers, right? That are people like you and I, right? I don't want my house power going out because the data center down the street caused something to happen, right? So that's part of it, right? AI is is the new leading edge, right? And we haven't seen the full impact, but how do we mitigate that impact without even knowing what it is? That's the challenge. And that's the same boat the utilities are in. That's where the question started, is they don't really know, right? Years ago with big aluminum smelters and things like that, big arc welders, right? We came up with a solution for, anti-flicker, voltage deviations to impact other customers, right? And that was fine because there was enough other load on the grid to stabilize it. But now, AI factories are going to be the load on the grid, right? And so if they're making these changes, what is it going to do to the remaining small percentage?
Great.
Yeah.
Brandon, I wanted to ask you,
Yeah.
same point. The utilities are dealing with this problem, as Shawn has said, which is genius, but it's impacting everybody. Are you at ZincFive seeing this also, where sometimes it's the utility coming at you, my friend? Sometimes it's the customer. Sometimes it's the wonderful person named Shawn, who's a genius. But what are you seeing? Are you seeing this from every area?
Yeah, and I'll preface that answer by pulling on something Nabeel said early in the call as well. As he said, we're very siloed, and I think nobody's more siloed than battery technology companies, because for the last decade we were left in a room by ourselves, and we were a liability and an OpEx and a back of someone's mind, right? Not at the forefront of innovation or technology, if you will. That's changed a little bit over the last few years. It's going to change a lot over the next 5 years. And what's interesting there is we've had to adapt to breaking down our own silos and talking with customers at a different level, getting integrated with your IT requirements, getting integrated with the rest of their design, not just what's the battery runtime you need? How do I put a battery system here? It's how do I use a battery system to build a data center that's more efficient, more sustainable, more powerful? How do I unlock the full capacity of AI, using battery technology? And that goes a step further to the grid. There's energy storage companies, right, who have put shipping containers full of lithium out at the grid for years, right? That's very common. But I don't think we've ever had the discussion between a battery technology company and a data center design builder and the utility on how do we leverage these technologies to bring a gigawatt level AI campus to market. And I don't know if we've had those conversations as in depth as we need to over the next couple of years, but that's part of just breaking down those silos. There's no more white space, black space, gray space. It's all AI, and it all has to mix and intermingle, and the requirements need to come from the IT rack and the electrical design and the utility for someone like ZincFive to build the right solutions to solve that. So break down the silos first.
Absolutely great. Break down the silos and unlock the power. I like the way you're thinking. Let's get to final thoughts. I know that we're coming right near the end. If I could, Shawn, to you first. I mean, the wonderful expression that you've all used all the time is it's impacting everything. AI impacts the entire chain, and here we are in silos. So, Shawn, to your final thoughts, what are you thinking here? Everyone knows what's going on now, and you're part of the solution.
Well, I think this items like this, discussions like this, panel discussions like this, where we're getting it out in front of people and saying everybody is in this together, right? Not only as an industry but as a globe, because it's impacting everything, right? And we need to work on solving it together. This is a critical item, and things like this are the right steps to be taking. Open dialogue, open discourse, everybody understanding. Let's work together to get the solutions, because we want this to be a thriving industry, right? And the NIMBY, not in my backyard, right? We don't want that to impact data centers. We want to be valuable assets, right? Whether we bring additional things, whether it's tax revenue that everybody talks about, but additional resources, whether it's people or critical services into the area, right? I think we can provide a lot of good. We just have to understand the negative impacts we could have and work together to mitigate them, right? That's the biggest thing, working together. I think we've said it multiple times, but that's where we're at in the industry right now, is we need to work together to understand and mitigate the impacts that are going to happen outside of the fence line of the campuses of data centers, right? Because that's what people care about.
Nabeel, to you.
So we have been the best kept secret for the last 4.5 decades. The cat's out of the box, and for a good reason. So if you're not planning for it, you're already behind it. If you don't talk about it, you can't build it. We are actually one of those rare industries where everything is up for innovation. And I would suggest it's time that we use it wisely. We build smarter, we build resilient, and we build sustainable infrastructures for the future. I would want to leave this place better than it's been given to us for the next generation.
Absolutely perfect. Brandon, to you, sir. And I have to say, Brandon, to you and to everybody at ZincFive, thank you for sponsoring this time. And to Shawn's point, and to Nabeel, you got to talk about it now. So thanks for actually hosting this. You started this conversation, Brandon. Appreciate it, my friend. To you, final thoughts.
Yeah, no, we're absolutely happy to. We love talking about these things. I mean, the reason Shawn and his team are at the cutting edge and one of the best companies on the marketplace is they're having discussions like this with their vendors, right? We can come and show new test data that is fresh off the engineering floor on what we think is capable of our technology and what we could build with that capability. And they can give us honest feedback about what's going to work and what might not work. It's that level of partnership, right? It's not a commodity. It's not a supply chain item you check off the list that you're procuring. Battery technology, I believe, will be the solution to a lot of the AI dynamic workload issues. And being able to discharge into the grid and recharge quickly will solve a lot of these issues. But it takes these conversations, breaking down the silos, sharing data as soon as you have it, and spreading the requirements around and having honest discussions with the marketplace, because it's going to take a lot of very intelligent people talking about this for some time to get a direction that we can build in so that 1 gigawatt of rack is a realistic item for us to shoot for.
Thank you. Nabeel, Shawn, and Brandon, you're the best. Thank you so much.
Well, thank you.
Thank you for having us.
And with that, I've got to say thank you very much for joining us, and to ZincFive. Don't forget, we have a lot of great resources that are available. Also, reach out to each one of our panelists. And don't forget, this episode will be on demand. And don't forget, tune in for the next episode coming up at the top of the hour. And thanks for joining us for this entire AI week. Appreciate it.